My name is Derek Draper, and I am a senior drilling engineer for Mewburn Oil Company. We typically start out, we'll drill our surface hole, and then we'll set surface casing to protect our water sands and our drinking water. And then we'll drill vertically down to a kickoff point, and then we'll trip out of the hole. We'll pick up our directional tools, which consist of a bent house motor and some logging tools that tell us what our angle is, and reads gamma ray, which will tell us what formations we are drilling currently. And then we'll pick those up and we'll drill part of our curve with those tools, which is our curve section. We'll set another string of pipe to cover up some zones behind pipe that we find challenging, or to protect us from lost circulation and stuff like that. And then we'll continue our curve, and then we'll get our wells landed into a horizontal situation. And then we'll drill what we call our lateral, or our horizontal section, which typically consists of about 10,000 foot typically these days. We use math every day. We have several calculations that we do to calculate volumes and to calculate pump outputs and pressure drop and stuff like that. And also we use trigonometry and cosine functions and stuff like that to calculate our build angles, our build rates, and determine how much build rate we need to hit our horizontal zone that we're looking to target. And as we go through there, and we'll use those calculations every time we take a survey, which we take about 30-foot surveys. And we'll take those surveys and we'll calculate our build rates that we're getting there and how much build rate we need and everything to where we want to land our horizontal section. So what build rate is we start out drilling from kickoff point, and this kickoff point is a predetermined spot that we're going to stop. And typically we build a 10 degrees per 100 or 0.1 degrees per foot curve. So we know that we need to meet this goal of 0.1 degrees per foot. So we go in there with a directional motor that typically for our applications in an 8 3/4 inch hole will typically give us anywhere from 0.12 to 0.15 degrees per foot. So as we're drilling this curve, we are attempting to get this 0.1 degrees per foot build rate. And a lot of times we will get more than the 0.1. We will get 0.15 sometimes, and then we have to, so instead of 100% sliding with our motors, which sliding is basically we orient our motor in a direction we want to go, and the motor is doing all the work, whereas rotating while drilling, the whole drill string is rotating, so we don't have control over the direction that we're trying to go. So, and if we're getting more build rates than we need, we can't 100% slide, because then we will come in high to our target zone. So we will have to do some intermittent rotating while building our curves to get the build rates that we need to hit our target angle. So for instance, if we're getting 0.15 degrees per foot or 15 degrees per 100, and we need 10 degrees per 100, then we would have to change how much we're sliding. So if we're getting 15 degrees per 100 and we need 10 degrees per 100 or 0.1, degrees per foot, then we would rotate 20 feet or rotate 10 feet and slide 20 feet to meet that need. So as we're going through this curve, we're constantly changing because nothing in the real world is ideal. We would love it if we got exactly 0.1 degrees per foot the whole way, but it doesn't work that way. So we have to adjust on the fly. So my directional drillers, which is a crew that we have out there, they are constantly calculating how much sliding and how much rotating they need to do per joint of pipe that we're putting in the ground so we can adjust and land in our zone. Typically, we're at about 9,500, 9,500 foot TVD at this depth, and we are landing in a zone that is only 10 to 20 foot thick. Imagine the height of the classroom you're probably in is only about 10 to 12 foot thick. Well, we're trying to target that zone from 10,000 foot away, and we're trying to land exactly in that zone. So we're having to take constant surveys and constantly make corrections so that we can land exactly in this formation that we're targeting. The primary responsibilities of this job is to work on well design and control day-to-day operations of how we're drilling a well in northwest Oklahoma. When I was in high school, I decided early on that I really enjoyed math and I enjoyed science, and I knew some engineers that my mother worked with through her job, and she thought that it would be something I enjoyed. I looked into it and decided that it was something I might enjoy. And then when I decided to go to college, I decided to go to Texas A&M University, and they offered me some scholarships to join their petroleum engineering group. So I started studying petroleum engineering and really, really fell in love with the field and just decided that it was something that I was interested in doing. And then I did a couple of internships in the summer with Mewburn Oil Company. This was back in 1997 and 1998. So I've been doing this a long time. Advice I would give to students would be to get as much math and science and chemistry background as you can in high school. I wish that I would have taken an extra year of chemistry and perhaps even physics while I was in high school. It would have made me more prepared for some of the classes I was fixing to get into in college. My job requires a bachelor's degree in petroleum engineering or mechanical engineering. We have some engineers that work for Mewburn Oil Company that have mechanical engineering degrees, so either one would work. But they do require, which is a 4-year typical university degree to get. It's roughly 135 to 140 credit hours. We have people that work on the side of our field that have come up through the industry that are some drilling foremen and drilling superintendents that they do not have an engineering background. But to do what I do, yes, they would need some sort of engineering background to help them understand some of the things that we do.